This is Amisha Paul from Galgotias University, Greater Noida. In continuation of my previous topic under the aegis of FDP on environment and sustainability, today I am going to present carbon footprint calculation of a pharmacy. These are the details of my week 1 and week 2 videos, which were earlier shared with you. In week 1 video, we discussed about the green pharmacy and its importance. And in week 2 video, we discussed about the standards related to the environment to green pharmacy. The learning outcomes from this video, a student will be able to identify various guidelines related to green pharmacy, comprehend carbon emission and carbon footprint, analyze greenhouse gases, greenhouse effect, and global warming, estimate carbon footprint calculation. Then only the main goal of this FTP will be achieved. Let us have a look at the learning outcomes from my week 2 video, which discussed about the list and the guidelines and the rules related to green pharmacy. And we discussed about the WHO guidelines 1999, biomedical waste management and handling rules 1996, Drug and Cosmetics Act 1948, ISO 13940-2015, which deals with health informatics system of concepts to support continuity of care, ISO 17523-2016 guidelines, health informatics, which deals with requirements for electronic prescriptions. Now let us see what is carbon footprint. The sum of the emissions of carbon dioxide which are induced by human activities in a given time frame is called as carbon footprint. Usually a carbon footprint is calculated for the time period of a year. Actually, the total amount of the greenhouse gases produced directly or indirectly to support human activities is usually expressed in equivalent tons of the carbon dioxide. Greenhouse gases are those gases in the atmosphere that have an influence on the Earth's energy balance. A greenhouse is a gas that absorbs and emits radiant energy within the thermal infrared range, and the gases are water vapor, carbon dioxide, methane, and ozone. They all contribute to the greenhouse gases. These are gases which allow direct sunlight, that is relative shortwave energy, to reach the Earth's surface. As the shortwave energy that is visible and the ultraviolet portion of the spectra heats the surface of the Earth, longer length waves like infrared waves are re-radiated to the atmosphere. Greenhouse gases absorb this energy and thereby following less heat to escape back to the space and trapping it in the lower atmosphere. The man-made include chlorofluorocarbons, hydrocarbons, and so on. Atmospheric concentration of both the natural and man-made gases have been rising over the last few centuries due to the Industrial Revolution. As the global population has increased and our reliance on fossil fuels such as coal, oil, and natural gas has been firmly solidified, so emissions of these gases have risen. Carbon footprint can be calculated at the different product stages like for transport, electricity, natural gas, materials, and waste disposal. This is a system diagram and life cycle stages in pharmacy. Level 1 and 2 include finished pharmaceutical products, then distribution and delivery, then the final use, and that is the end of the life cycle product. Calculation of carbon footprint in a pharmacy includes Step 1. Carbon footprint of transportation, carbon footprint of electricity, carbon footprint of packaging and paper, carbon footprint of water, carbon footprint of employee commuting, and finally carbon footprint of waste. The carbon footprint of transportation, which is denoted by A, is carbon emissions is equal to transport volume by transport mode multiplied by average transport distance by transport mode multiplied by average carbon dioxide emission factor per ton kilometer by transport mode. Now let's take an example. If a truck travels 1000 miles with 20 short tons of cargo, carbon footprint is 3.24 metric tons of carbon dioxide. Now the second calculation is about the footprint of electricity, which is denoted by B. The the carbon emissions equal to hours into days into watts into emission factor divided by 1000. Now let's take an example. A computer used in pharmacy is operated for 8 hours with power rating of 450 watts. So the carbon footprint is equal to 1.06 tons of carbon dioxide. Likewise, the carbon footprint of packaging in paper is denoted by C, and the formula for that is use kg per week multiplied by 52 multiplied by emission factor. And carbon footprint of water denoted by D is use liters per day multiplied by 365 multiplied by emission factor. Likewise, carbon footprint of employee commute is denoted by E, and emissions is equal to distance travelled multiplied by the emission factor. Carbon footprint of waste denoted by F is equal to waste kilogram per year multiplied by the emission factor. So total carbon footprint can be calculated on the basis of the cumulative carbon footprint at each step. So carbon footprint of transportation plus carbon footprint of electricity, packaging and paper, weighted employee commuting and waste, that becomes A plus B plus C plus D plus E and F. That gives the total carbon footprint of a pharmacy. Sustainability. According to Brundtland Commission report of United Nations in 1987, meeting the needs of the present without compromising the ability of future generations to meet their own needs. So sustainability is a cycle, sustainable growth and innovation, low carbon, circular economy, responsibility and stewardship, people and community. A sustainable approach to pharmacy can be reverse logistics. Reverse logistics is a set of activities that is conducted after the sale of a product to recapture value and end the product's life cycle. It typically involves returning a product to the manufacturer or distributor for forwarding it on for servicing or recycling. Now the following diagram represents how reverse logistics can be obtained in a pharmacy. So concluding my presentation here, we bring bigger ideas and smaller footprints together. Thank you.